Welcome back to another part of our engine series. Today we are looking into how to program ENG-004, which is the crankshaft part of our engine assembly. As you can see, the crankshaft connects to, well, it connects to the connecting rod, which will connect to the piston, which will move up and down, right? Um, Turn that off, get that out of the way, turn that on. So we'll take a look into this part. It's not too bad of a part, but just as before, we probably, because it is an odd shape, we might have to look into making some jaws, which everyone seemed to have a fun time from the first time we made jaws, because a lot of people that are listening to this video have been using CATIA. Um, Today, we'll take a little bit more of a look into how else we can do it. For instance, making jaws in Mastercam, because that has that capability. So opening up our ENG-004, we can see that we have some kind of like a half semicircle type shape with a tapped hole on one side. On the other side, we have a shaft that has these cool little, I guess, grooves, which just allows whoever is turning it to have a little bit of a grip. Or in the future, this could connect to a timing belt, which would connect to the camshaft, which would control the intake and the exhaust valves. If we look at this, we can see, okay, some couple things. So the external radius of this part is 0.625 inches. So we'll have to take a look at what stock we might want to use for that. But I kind of have a good, well, decent idea. I don't know. We'll see. We'll have to see. Radius on the inside of these grooves is 0.0625. That's a good note to come back for later. And you can see our 1032 dash tapped hole. It goes, it's 3/16 of an inch deep. So let us get into it. We can open up Mastercam, which apparently Mastercam is not open for me right now. So let me open it up and we will get started. Okay, looks like we're loaded up and ready to go. Let's open up our step file, which we'll find in this folder right here. And we'll search up all files to find all my different files, and we'll find ENG-004, which is the crankshaft. Um, Let me open up let's actually take kind of maybe a little screenshot of this might be nice. Just so we can start to plan out what we need for stock. This is what our stock's going to look something like. Start to fill in some dimensions. I like to use Fusion for this in my measuring. This is a 0.625 radius, but we don't need full. If it was a 0.625 radius, that would mean a 1.25 inch diameter of stock. But since it's not a full circle, we don't need all that. So let's get a measurement from here to here. Let's find our crankshaft. I might need to make a sketch for this to get a proper measurement. You guys might have better measuring tools than I do. right about, doesn't have to be too accurate, but let's just say there to here. You can just inspect this line, see what we get. We get 0.88. Okay, so sorry, I just took a pause there because I saw my network was dropping. Looks like we're back. So 0.88 inches. Okay, we can fill out our thing so we know in this direction we need 0.88. So probably we'd look at like 1-inch stock here. I'll just put 0.88 in brackets for now. In this direction, we can try to draw a line just about from right here to about right there. I mean, it's fine. That length is 1.23 inches. And lastly, from here to here is 0.99. From top to bottom, 0.99. Okay, so we can plan this out. Now, I think we should definitely use 1 inch for this side. I like that. So we'll get rid of that one. That one's done. I know either we have 1 by 1-inch stock, so I could make it 1 and then 1, and we could cut it to 1.23. But 10 thou is not a lot of extra material, especially when you have to face the top and the bottom of your part, plus needing a carrier. We don't really need a carrier for this part, actually, as you'll see, but it doesn't work out that well. We might want a carrier. We'll see. We will see when we get there. So let's up this. How about let's do the 2 inches in this direction. So 2 inches, 1 by 2, and we'll cut it to, well, we'll want 20 thou for the top to face. Now we'll talk about whether or not we want a carrier. So op 1, I imagine us machining this bottom piece, and there's no reason why, so we'll machine up to right here basically from this side. There's no reason why we need to go all the way through the part because we have this underhang here. So then we'll just machine that from op 2. So if we machine about to here, that would mean that we're sticking our part out of our vise without needing a carrier. So let's just add 20 thou, so that gets us 1 point or 1.01. Let's add, so 1.01 gives us 20 thou on the top. When we flip it around, we'll want at least another 20 thou to face. We don't need a carrier. Sometimes I like to have a little bit more clearance, especially for cutting to that size. So let's do it where we add, let's do 1.25, 1.25, 50 thou on each side. Maybe 1.1 inches will be safe. 1.1 inches, that will give us at least 50 thou on each side. When we cut on the bandsaw, we should be able to get that. Like I'm worried about the bandsaw cutting, little or less. We could always cut a little bit more of the bandsaw, just be careful. So nothing less than 1.1, we'll make sure. So 1.1, 2 by 1 by 1.1 will be our stock size. I know I said earlier that we could machine part way down from this face and then machine everything op 2, but now I'm thinking let's actually make a carrier on the bottom. Let's machine all the way down. So we do want a carrier on the bottom. So know what? Let's actually update this drawing. Instead of 1.1 inches, let's do something a little bit more. Let's do 1.05 1.25 inches. I like that. Okay. I see the vision now of how I want to machine this. I've changed my mind. So let's do it that way. So op1 is going to face up. Um, I've already went ahead and created my stock level. So if you haven't already, you could hit plus and create a stock level. And then we'll go and create our bounding box. So going to the wireframe tab, clicking bounding box and selecting our part. Um, First thing we want to do is go and make sure solids and lines and arcs is checked off. And then we can manually set up our um, plane. We normally would have a nice corner to grab. Everything you've done so far, we've had a nice square part where you can kind of grab something off of it. Here, we want to make sure we select somewhere that's in the middle of our part. That way, when we add stock to the X and the Y, it adds it equally each way. Luckily, Mastercam puts this little datum point in here, which is kind of like the center point in our X, in our Y, in our Z. So if we just hover over that and click on that, and then just rotate it so that our Z faces up, our Y faces back, and the X to the right, we should be really good. I'll hit enter. Now I know my X is going to be 2 inches, which is a little bit of a waste, but it is what we are working with the material that we have in stock. Our Y is going to be 1 inch, and our Z is going to be 1.25 inches, adding that little bit of extra stock on the bottom. I am then going to hit OK. I believe everything's good. And from there, I'm going to turn on my wireframe for view. And I'm just going to transform by going to transform and do a translate, clicking my actual part and just moving it down below the surface, 20 thou, being 20 thousandths of an inch for facing. Once I hit OK, I could right click and say clear colors. And there we go. Now, because this part, it's a little bit different. It's a different part. Normally you have a big face on the top of our part to machine. So typically we start with a face mill and machine it away. But I'm thinking like this diameter of this, I believe is about 0.375 inches. So if we use a 1/2 inch end mill in this program, we actually should be able to face that top face with a 1/2 inch end mill. Now we would probably want to do that after the OptiRough because we don't want to leave a streak, just one streak going down the part. It doesn't really matter, but in my opinion, let's rough out all this and then we'll come up and add the face after. I know typically I say, face should be one of the first things you do, but I believe it might be nice and you can see my vision when it comes alive once we do this. Okay, so before we go ahead and do that, we do have to make our planes. So if we go to our planes tab, we'll create a new plane. I just like to actually click on this little axis down here. And our part, we'll want our plane based off our stock probably. So we can do the back left corner like we typically like to do. Axis, press OK / double click the mouse to accept the results. Interesting. Normally I just press enter, but I guess I had to double click. I will call this my G54. And I'm going to set everything equal to that. We will set up our G55 later on after we make the jaws for Op2. So as I said, we're going to start with an OptiRough. Okay, I know typically we normally face it with a face mill, but there's no sense in using an 1.5 inch face mill, machining this entire face. It's a lot of time, it's wasted, when in reality, 95% of this face that's going to be, beautifully faced to a nice machine finish is just going to be gone after our OptiRough. So in this case, let's start with the OptiRough. Let's set our wall stock and our floor stock both to 5 thousandths of an inch. Let's go to our toolpath control and let's select, well, actually, sorry, before we go there, we actually have to tell it what it's machining. So let's select our machining regions. To do so, we got to turn off our stock level and we'll triple click our part so that we can select the entirety of it. Everything should be green. We don't need any avoidance regions. We can move on to our toolpath control where we will select the outside of our stock. So just even the top face works. That tells it where our tool is allowed to go. Our tool should be allowed to move from outside, compensated to the outside, about a distance of just even the diameter of the tool, like 0.375 will be nice. Our tool that we'll use, I don't know why it says 3/4 inch end mill. I don't want to use that, so we're going to select a new tool. And I'm deciding between whether or not I want a 1/2 inch end mill or a 3/4 inch end mill. Um, let's see, what's the height of this? It's about 0.75 inches, so we need something with 0.75 with the flutes. I believe we both have a 3/8 end mill and a 1/2 inch end mill that is able to do that. So let's use, I mean, typically I like a 1/2 inch end mill. I'm just trying to plan what tools will be available for us. Let's use a 3/8 end mill. It's a pretty small part, so might as well use a 3/8. Gotta go back to my mass cam. That's what I'm looking for. Let's use a 3/8 end mill. With my 3/8 end mill, I know that I could go pretty fast. Let's go 15,000 RPM. Let's do like a 3,000 chip load. Yeah, 225. I like that. It's nice and fast. Plunge rate, it should be plunging outside of the material, so we can set that to 100, making sure rapid retract is on. And actually, sorry, I want a 1/2 inch end mill because I'm gonna face off the top, which will be about half. We want a 1/2 inch end mill for that, so let's switch that out. My bad. Double click on this. We'll set this to 1. Finish. Let's do a spindle speed of 12,000 and probably about 200 inches per minute will be good. That all works. My stock, I do want to say rest material. Did I not make my stock model yet? Oh my gosh. Okay. I will come back to this. Let's finish the parameters. I will come back and make my stock model and then do that. As you guys know, anytime we make an OptiRough, we should make a stock model first. My step over, I like about 15%. My step down, typically for my end mills, I can go about 0.75 inches. I might be able to go, let's just do 0.75 to be safe. And we do want to check off step ups, and I normally keep that about 10%. Steep and shallow, so minimum depth is going to be, well, basically the top of the part will make it, which says it's 0, but shouldn't. Oh, my plane has to move down as well. I move my part down. My plane also has to move down 20,000. I think I made the same mistake in engine 1 as well. I'll come back and fix that as well. So we'll come back to steep and shallow. Plane should be good. Coolant will turn on, and then we'll just come back and fix everything else up that we missed. As we can see, it does not look right yet. So let's move our cursor above that. Let's go to create a stock model, turn off our stock plane. Let's select our initial model, which is our stock level. Let's turn our solids back on, making sure to triple click this, select that stock, and hit OK, and OK. So now if I turn off my, whoopsies. If I turn off my stock, there's my stock model. That looks good. I also need to update my plane. So let's go to G54. Let's hit edit and let's move this down 20,000 so it's at the top of my part as well. Okay, hit OK. And we can go to our toolpaths now and we can update our stock model. Okay. And we can go and update this toolpath. We'll go to our stock. We'll turn on rest machining, rest material, and select one other operation in our stock model. We'll go down to steep and shallow. Our minimum depth will be now the top of this stock because we might as well cut that, sure. And our maximum will be about the bottom of the part. So if you go right about here, but we can break through a little bit. So let's do another 50,000. Linking parameters, back feed rate, let's do 500. Clearance, we can change to 1 inch. Everything else is good, good, good. Hit OK, and we should have a nice OptiRough. Non-OptiRough. Okay, let's figure out why that is. Let's go back to my toolpath control. Outside, offset distance 0.375. Will that help you out? I'm guessing it will. Yes, it will. Perfect. Okay. So let's check out this toolpath. Step overs look a little big. I might want to, no, actually not too bad. So steps down, cuts there. And then it works its way back up and cuts right here. I don't like that. The reason why it's doing that my step down of 0.75 landed me about right here. Sorry. And then it did the next step down here, and then it saw this face as like the little bit of stock that was here as something that hasn't been machined yet. So it's like, oh, we got to go back up there and do the step up, but that's a waste of time in my opinion. The step up top is nice to have done, so we'll leave that there. It kind of cuts a little bit of the roughing off this part, that's fine, and then it also sort of does a preliminary face of our part to leave only 5 down the top of the part. So nothing wrong with that. But we will want to make maybe just my step down a little bit bigger. But we got to be careful. I believe my tool should have, my 1/2 inch end mill should have more than enough. So if we go like 0.8, that should get us below that edge, so it doesn't have to step up and recut that. Now well, that's fine. It cuts down below like this, then it steps up and cuts that, but it's not wasting as much time anymore. Awesome. So let's do that. Again, 0.75 is a safe number, but if my end mill, when we get to the shop, if we have an end mill with an inch overhang, an inch of flutes, then we'll probably be able to cut this entire part all at once instead of stepping down, which will be nice. But for now, we'll leave it here just to be safe. And we'll come back to that. Now we could do the face. So when you do the face, we'll just click on face mill. Whoops, let's hit X. I don't want this anymore. No, it made it in the wrong place. Let's just drop my cursor down underneath my dynamic OptiRough and try that again. So let's do face. And I should just be able to select this top face here. Go to my tool. We will select my 1/2 inch end mill. I like working at 12,000 RPM and about a 1 thou chip load for my finish, which gets us about 48, or I just typically do 50 inches per minute. My plunge rate could go to 100 inches per minute because we're not going to be cutting on while we plunge. This should only need one pass, so we'll just do one pass because it's a 0.375 inch kind of diameter and it's a 1/2 inch end mill. We want to make sure that there is 0 stock on the wall or on the floors. We do not need depth cuts. Might as well turn our 1 inch clearance on only at start and end. We'll make sure everything is in absolute. And our retracts, I always do 0.1, 0.1. Top of stock is going to be actually about 5 thou left over from our OptiRough, and our depth is 0. Our planes are correct. My coolant should be turned on, and I can hit go. Now you can see my tool comes down, cuts across, and goes up. Now, if we really want to save some time, we could change the along overlap to be a bit shorter. So let's do about 102% maybe. That probably did nothing. Let's shorten it to about, I guess I could do 0.26, which is about half the diameter of the end mill. So my end mill should start off the stock where it is, barely. In fact, that's a little close. I might want to extend it just a little bit more. So let's do 0.275. Let's just do 0.3. 0.3 is a good number. Just saving some time, right? Every second counts. Beautiful. Okay. We can continue on to finish up or finish everything else. So to me, I see we could do a contour here, a contour down here. So let's do a one contour. Let's select, well, actually we got to do this face as well. So, and that face could be part of our, like we can machine these two at the same time if we do like an area mill finish. So let's just start down low. Might as well, since we already have the contour selected, let's just select that. Make sure my direction faces correctly. I want it climb milling, and I'm kind of strategically putting my starting point right at this transition, because when when your contour comes around, and even if it overlaps, it will leave a little bit of a mark. If we just line it up right at kind of a transition point, it kind of hides that mark. It kind of looks just like the edge of the radius instead of a starting and ending point. We will use my 1/2 inch end mill still, and we will do the same speed feeds, 12,050. Plunge rate, we could do 100. Retract rate, we'll do rapid retract. Cut parameters, we want to change this to wear, so we have some adjustability in case we're cutting over or under on the machine. And we'll do, we won't do depth cuts because we're just going all the way down to the bottom of the part. There's only about 1/4 inch or so there. No need to worry about that. Lead in, lead out. Since we're doing it at a corner, we probably don't need an overlap. About 0.05. Just keep it short. The shorter they are, the faster it feeds in. The more time you save, the more money you make, right? 1 inch, only at the start and end. Absolute all the way down. Our retract is 0.1. Our feed plane, I like to be 0.1. Our top of stock is 0. Nope. Top of stock is about right here technically, but it's like, I guess you could say that there's still about 5 thou on there. So if you want to be perfect, you could write that. Doesn't matter entirely, no. But for my depth, let's select the bottom, and we want a breakthrough, and let's keep it consistent with our OptiRef, which was 50 thou. Planes, coolant, continue to turn it on, hit OK, and there. And if your contour, like mine, actually didn't show up on that edge, you can see it's actually at the middle of the radius, go back into your lead in, lead out, and turn off enter, exit, midpoint in closed contours, and that will now put it right at the edge there. So when my tool comes in, it starts on that radius, and it will hide that starting and ending point. That is nice. We will then do, I'd like an area mill. You could machine this bottom and the sides separately, but might as well do them together because we have that feature. So machining regions, we will just say, you could say the top, but we probably want to make it just the outside of this chamfer, just so that our tool doesn't miss that last 10 thou, even though it will be chamfered off later. That's our machining region. We could just say from outside, so it knows it's allowed to move outside that region. And we do want to avoid this, so we don't cut into that. And we can see our chain says everything in red was what will be cut. Nothing in here will be cut, and it shows that our tool is allowed to move from the outside. Our tool, we'll set this once more, 12,050, and plunge rate is 100, and rapid retract should be on. Our cut parameters, we will do 0 on the walls and the floors because this is a finishing operation. Our step over, let's just put it down to about 33%. 45 is also fine, but 40, 30, or 45, it kind of touches the wall at the same time, so we might be able to do that. So no depth cuts. Finishing passes, we will have one finishing pass, and we'll leave that about 5 thousandths of an inch of material. So that's in the X and Y. Once it sees the inside wall, it should leave 5 thou, and then it will come back in and then machine it one more time. That way it just does the wall kind of, it will do like the floors by itself and the wall. If you're finishing the floor and the wall at the same time, it kind of, I guess you could say it just creates a little bit more vibration, which can affect your finish on your part. So whenever possible, if we can machine the walls separately than our floors, might as well. No harm to it. Our top of our stock in this case is up here, which is 0, and our depth is down here, which is not correct. Let's change it to absolute, and U should be absolute as well. Change it to U. No breakthrough on this one. No entry motions. Coolant will turn on, and let's see what this looks like. Beautiful. So you can see it cuts it once, and then it comes back in and does that last 5 thou. Now there's not really an entry motion on that last 5 thou. Where? I want to see that. So when it comes in for that second cut, it comes straight down on my wall, or is it slightly away? I can't tell. I don't like it if it's coming straight down on that wall. It's really, really close. When it does this thing where it comes straight down, it doesn't look like it's on the wall, but it will create a sound. Can we add a lead in and lead out on our finish is my question. So let's go to our finish passes, lead in, lead out. There we go. That way our tool's just not dropping straight down. It doesn't have to be much, even 25 thou if we really just want to be tiny. And might as well, because we are wrapping all the way around, we should add somewhat of an overlap to try to hide the tool mark at the start and end as much as possible. So now it feeds in. Oh, I forgot to do my lead out. You can see my lead out's huge. Let's copy that over. Okay. There we go. There's my lead in, lead out for my finish, which is much better. There we go. So we have the outside finished or roughed, finished top, finish there, finish this wall. Looks like all that's left to do is these little kind of grooves. We can take a look at our drawing, or which you could see on the inside that this radius right here, there are 0.0625, which means that we have to, the biggest tool that we can use is a 0.125 inch end mill. We probably don't want to go smaller. This, because it's a 0.125, I'm a little bit worried about the finish we're gonna get, but let's see. That'd be pretty cool if I did that for you guys. No, we can't do it that way, never mind. 0.25 inch, okay, so it's only like two times diameter cut. It's not a lot. So let's probably 2 passes. We'll step it down 1/8 of an inch at a time. Kind of general rules apply that you want to. The outside little bit has already been machined, but we will just select this line as our contour. But we're gonna have some issues, I'm gonna tell you right now, probably. Because I'm gonna select this bottom here. Unless, do we, unless we don't machine the outside, we avoid these so that keeps a nice finish just on this little tiny part that's still the 0.375 diameter. We just machine there. We could make a contour going all the way around, or we can make separate ones. How about let's try to see what a separate one looks like and see if it looks okay. So let's just do a contour, and I could select the start, and if I hold shift, I could also select it from the start. Oh, normally you can. Whoops. Chain. Normally you can just select the starting position and the end, and it should make a line there, but it doesn't look like it did. So maybe that's just a Mastercam lathe thing. Let's flip the direction, and let's select that as our contour. Actually, sorry, 1, flip, 2, 3. Then we'll go over here, 1, flip, 2, 3. And you don't have to flip it if it's already facing the right direction. So if you grab it on this side, it should go the right direction right off the bat. If you grab it on the first half of this contour. Okay, make our way around. Really? Nope. Stop. If you ever mess up, you just press this unselect. It'll unselect the last one. Done. 2 more. 1 and 2. Okay, let's see what this looks like. The less, if we don't have to have the 1/8 of an inch end mill touching this outside, it'll probably make a better finish because the 1/8 of an inch end mill is going to vibrate a lot because it's such a tiny diameter. So the less we have to cut with it, the better. So we'll select the library tool. We'll use an 1/8 of an inch flat end mill. We will want it at about 12,000 RPM, and well, my roughing. So if I do because we're doing a finish, right? So if I do a 1 thou chip load for a 1/2 inch end mill finish, this is about 1/4 of that. So really I should do 0.00025 for a finish, which gets me about 12 inches per minute. We can probably go up to 15. Plunge rate 100 looks good. Wear is nice. No depth cut. Yeah, depth cuts. Do 0.125. 125. Don't need a finished depth cut. We will keep tool down, lead in, lead out, make these really, really small. We'll see how that looks in the end. We don't need any overlap. 1 inch, 0.1, top of stock is 0, and our depth should be right about here. And we do not want breakthrough on, and we want to make sure coolant is on. Now, hopefully, I can't really tell if we're crashing into our part on the lead in there. Let's take a look. So there, you're touching. It looks like it's touching the right part. It's hard to see. So if you lead in like this, you lead out. I think that looks good. Just lots to see. Now, see how it's retracting all the way up? That's a lot of wasted time. Okay, so it does one. Oh, I see. It lifts up and does the next contour. So let's do. Look at all these lead in, lead outs. Let's do retract. We can probably change. Let's retract. What if we don't do retract? How would that look? No, you still do that. Feed plane is 0.1. Can we make feed plane incremental and do 10 thou? Would that speed things up? Still going up to clearance, so let's get rid of clearance. And it's still going up, which would be our feed plane 0.01, which is incremental. No, what's it going all the way up there for? Goes up. Only at start and end. So clearance should be really an issue. It says only at start and end of operation, so it's just a lot of time, right? I don't like that. I don't want clearance. My retract, it comes down, comes up to this green. What is this? Well, that would be your feed plane, 0.01 incremental. What if we did minus 0.24? Would that keep things down? And your retract was off? Okay, this is kind of sketchy, right? The second we start going to negatives, we want to be a little bit worried. I would like our feed plane to be based off of where the cut is happening. But it doesn't seem to let me do so. Not letting me turn it off. So if it's not letting me do that, do we try to tell it? We could define the contour a little bit better, but or we just select it all the way around. What do I like? What do I like? What do I like? So my question is, so if it's like this, it's gonna wrap it down, it's gonna cut. Oh, then it has to go down. Okay. Then it cuts. Then it goes up, then down, up, then down. Okay, that's actually not bad. That movement has to be there, but I would like it to jump across. I wonder if I could stop it from going up and down and work at the one height before it goes down. By depth cut order, by contour, or by depth. Bam, that's what I'm looking for. Instead of being by contour, now it will do this. Cuts in, tool stays in the whole time. Beautiful. I love that. Now I might want to go back to my linking parameters and see if I can. I wonder if I put that to 0.1 now. No, now it goes up every time. So let's get rid of that again. 0. That was what? By depth. What did I have this at before? And I'm confused. I had it. 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 Minus 0.25. We will. I want to see if, but if I turn clearance on, then everyone goes to clearance. It should, and it. I wish it was only at the. It says at the start and end of operation, but I wish it was not every contour. Okay, let's turn it off. So that should mean that my tool will wrap it in. We gotta be careful, and it won't lift up until the very end. And we'll go around. Go around. I like that. Oh yeah, that works. Good. That is our op1. We just got to chamfer that. So let's do a toolpath. Let's do a model chamfer. Select my geometry, this top edge, make it go all the way around, and I will flip the direction so it goes that way. My tool, well, my 1/8 of an inch end mill, I forgot to tell it the tool number, but that's going to be tool number 2. Finish, select library tool. We'll do let's do a 1/4 inch chamfer mill, sure. When I chamfer, I like 12,060. My plunge rate 100 with a rapid retract on, and my 1/4 inch chamfer, I should also change the number to number 3. Chamfer width, we can set a 0, bottom offset. That's fine. Let's change it to a top offset of 0.05. I like doing top offset sometimes, which means that there should be 50 thou of the tool above, which just helps make sure there's no chip form there, which it's such a small chamfer, we shouldn't have a problem, but it doesn't matter either way. This, keep at, we can set it to where, I guess. Depth cuts, no depth cuts, lead in, lead out. If we want to do a 10 thou overlap or something like that, just make it sure it fully cuts. That doesn't really matter. Radius, let's just do something like a 0.05, 0.05. Clearance set to 1, 0.1, 0.1. Actually, yeah, whatever, that's fine. Coolant, turn it on and hit OK. And for some reason, I don't have a exit. Let's go to my lead in, lead out and see what's going on. I typed in 0.05, oh, under percent, that's why, 20%. Okay, there we go. Have a nice chamfer now. Beautiful. And there is op1. I believe we can watch our simulator settings. I could go to my files now. I can go to my stock setup and just tell it what my stock is for my simulation. Make sure to select your stock and not your stock model by accident. If you see it make a blue rectangle, you selected your stock model, and it creates some random thing in your levels, so be careful about that. Enter and selection. Good. I don't know what the heck up in all these levels. I don't want those. Let's clear all empty levels. Get rid of those. And we can go to our toolpaths. We can select everything and Mastercam. Oh, I guess I didn't get out of this yet. Okay. Verify. Something odd is happening, but this might just be rendering on my computer. See how it looks like it's flat lines? Sometimes that's just, if I turn up the precision, that might fix it. Try it one more time. Maybe my computer's just having an issue rendering, so it looks really weird. Okay, let me just double check that everything looks good. Our AirML should have a nice finish. We did a nice contour on the outside of the part. So I believe that is just a rendering issue. If I want to double check, let's just make a new toolpath group anyways, because we will be doing this. This will be called my op2. Maybe I'll go and rename this one. Right click, rename. What? This is being so rude to me. Rename. Oh my. Gotcha. And just because I'm picky. Oh, this is not making me happy right now. Thank you. I said thank you. Let me have it. Let me have it. Sorry, guys. It seems like my computer is getting a little bit bogged down right now for some reason. I don't think anything's in the background of Mastercam, so let's just wait till it chills out a little bit here. There we go. And in my op2, let's make a new stock model. Let's base this off of my original stock model based on all these operations. And my stock model, if I just click on my stock model, turn off my part level. What if I just make another level, deselect those two. If you see those like lines like that, that's rendering. Yeah, my rendering's really bad on my computer right now. So my part looks good in the end. Nothing's wrong. It's just my rendering on my computer. Okay, moving forward, we now need to do op2. It's everyone's favorite time. It's jaw time. Let's make some jaws, everyone. It's well, I already have a new level. Let's call this jaws. Or we can even call them op2 jaws, whatever you want. And this time, instead of doing it outside in a CAD program, which I typically like to use Fusion 360, but let's show you guys how to do it in here. Making sure that my op2 jaws is checked off, so when I import them, it opens it up into here. I'm gonna go merge. Well, I think I should have a model somewhere, so let me go find one. TM436, Titan jaws, blank jaw right here. Let's try this one out. Okay, here's one of my jaws. I'm just gonna start by rotating this to kind of the right plane. So my top of my jaw should be this, so -90. And I'll probably, I can't tell if my part's completely aligned with it, but I'm guessing it will be. So let's go 90 this way, -90. And that's pretty good. Looks aligned to me. Now, right off the bat, I can go mirror. If not, I could go transform, mirror. But let's do mirror. Let's mirror it. I want to mirror it right here, but I want to mirror it about 0.0625. Well, that's not right because 0 is here. If I go the thickness of this jaw, which I know is 1 inch, so if I make my mirror 1 inch plus half a parallel, that'd be 1.0625. Bam. Look who's smart. There we go. That works. So I just noticed, if you guys are wondering how I like figured that out, let's say I noticed that it was mirroring completely off this back face right here. I'm not sure exactly why it was choosing that point, but I know that this, if I typed in 1, that's the thickness of my thing, that moved the mirror plane to right here. And if you guys remember, we're going to put an 1/8 of an inch parallel in between my two jaws when we machine it. So I typed in half that, so my mirror plane was set right in the middle. And I will make sure it says copy, and I'll hit OK. I will want to just double check that, for one, just the distance between here and here is 0.125. And that is the case. I always like a 0.125 gap, pretty good. Sometimes you might have to make it bigger, smaller, depending on how much material you need to hold onto your part, but for now that works. Next thing I guess we can do is also, we'll go back to transform, we'll do dynamic again. We're gonna grab onto these two parts, and let's grab the center of these two parts. So right here, there's a nice dot, right? Grab on that. Remember, that's the center of our X, Y, Z. It doesn't really matter which direction this is, but what I'm going to try to do is, I wonder if I'd go to move, if it'll also give me that center selection up here as well. That would be really nice if I went over here. It showed me the center of this part, which looks like it's not doing that for me. Okay. So I'm just going to exit out of that for a second and just try to think about how we can find the center of this part. If I go here, I could do solids. I'm just going to see if I can figure out a way to make that point that it was showing us before. Under model prep, move, whole axis, disassemble. Nope. Wireframe. Probably not. That's fine. Unless, just let me draw something on. Oh, well, that's the center of the radius. It doesn't really matter. The part doesn't have to be centered. In the X and Y, yes. I mean, sorry, in the X, it's nice to be centered. So let's just start one at a time. Let's do this little by little. Let's go tool pass. Let's go, sorry, transform. Let's do dynamic. Let's select both of these guys, and let's still select the middle. Okay. And let's just move it in this direction. And for me, it's the X, but whichever one is actually in the X for you. And let's just grab the center of the part, which is right there. Okay, so now my part is centered in my X. My Y doesn't matter. You could actually kind of strategize how you want this positioned. Like you could do it like this, like this, like this. It doesn't really matter. It might be nice for us to line it up so actually the center is the center of um, that boss that sticks out, because we will have to make a cutout for that anyways. Unless we put a bigger gap, but no, there's not a lot of room on that side. So yes, we will have to have a gap for that. So yeah, let's just make the Y centered to the middle of that hole. Okay. And for our Z, we gotta just let's just reselect it. So let's just hit OK and new selection, and we'll select those again. This time we'll just select something on the top of the part for the parallels or for the jaws, and we want to move it up to basically the bottom face. I don't know what I selected there. I meant to select this, but we don't want it to sit down on it necessarily. We want it to be we want the part to be inside of it. So if we just move it up like even like this, as long as the top of the face is accessible. So let's hold on to about, I don't know, whatever, like 3/4 of the way up almost. You want to hold on to somewhat to get some good clamping on it. So even that will be perfect. Okay. Hit OK. And I'm going to right click and say clear colors. Oh, my jaws made a whole new level. So let's just change this to, let's clear my empty levels. And let's say op2 jaws, make it nice and clean and neat. Now I just need to extrude the shape out of it. Oh, this hole isn't centered with that bore, which is fine. That's okay. Sorry, I thought that circle I grabbed before was this boss, but that's fine. We'll work with this. This will work. Okay. So now what we want to do is we want to create some wireframe. Before we do that, it might actually be nice to make a plane for our op2. You'll see why, because when we sketch our wireframe, the wireframe will be created on the X and Y of the plane that's selected. So let's just make a plane for our op2 anyways. So let's just create a new plane. In this face, we'll just go here, and we'll select the inside bottom like that. That's good there. And then we'll move our Z up to the top of our part, because we always want Z0 being the top of our part. X and Y center of the bore, Z0 top of the part. We'll call this G55 and hit OK. Now, the way I see us doing this is let's do a wireframe. And you know what, for this, let's go before we do this, let's do levels. Let's turn on, we'll just call this jaw wireframe or whatever you want to name it, just so that we can put it in its own folder so things don't get too messy. And what we're going to need is we are going to need to basically get the outside of that part. So if we just say curve one edge, we can actually zoom in on this part. We want the outside chamfer, and if you hold shift, it will select a line entirely around. And there we go. And when we do this now, we should be able to turn off our part, and we have a wireframe that we can extrude. That being said, we can go to our solids, and we'll go extrude, and we'll select shift select, so it selects the entire line. Hit OK. We're going to check this off to cut body. And for the distance, I wonder if we can turn this back to wireframe, and we turn back on our part. We should just be able to select the bottom edge of our part, like so. That made an extrusion in only one of my parts. Let's go back to my solid extrude. Target, solid. I want this. Can I do multiple? It's only going to let me do one for now. for solid, just select a target body for solids operation. What if I change that to this? Okay, whatever, that's fine. Extrude cut, and we will hit OK and do it again. We will select this wireframe again, hit OK, and we'll make sure this time the solid is the other one. Hit OK. Now, hopefully that didn't cut it out of our part. That's good. Now, if you guys look inside, you can actually see that, or even if I just turn this to solid, you can see on the one side, this this boss is in this vise. So obviously that's going to get in the way. I don't want to use this thin extrusion, this boss, the 0.375 diameter, to locate whatsoever. My locating features, no, I don't like that either. We're gonna adjust. I'm gonna adjust the sketch a little bit. Sorry, guys. That's okay. We can probably work with that. So I don't like this because right now, as you can see, the part is being hugged on the Y positive part and the Y negative. So if you try to open this jaw up, it's going to bring the part with it. I don't want that. I want it so that it's just cut. I don't want it to wrap around the part. It should just go to the side. If not, we could extend it. Because since this circle is getting located in this one, we don't really need this jaw to locate our part. This jaw would just be for clamping and supporting in the Z. So I'm going to look at if I could just adjust this a little bit more. So let's turn off my part and let's do my wireframe. I want to create a rectangle, but I'm gonna have to type in the coordinates, aren't I? Not fun. Let's do a, trying to think of the best way to do this. Like I could make a line and I could make a line. Yeah, let's just do that. Let's just type out for my length of my line. Let's just type 0.1. No, sorry. And I just had to select the direction. Let's do 0.25. That works. Could be less. Maybe just 2.2. Okay. Hit OK and new one as well. And I'm going to draw a line from here. And I got to unlock the angle. I don't want the angle to be 180. I guess that would just be 90 or 0. No, negative 90, I guess. And the length, well, I actually want to, nope, I didn't want to do that. Weird. Maybe if I just start from the beginning, it might be easier. Yeah, just like that. And I want to go up to this line, but there is no line there. So let's actually let's just do a curve one edge. Let's do this. Hit OK. I don't know if this, I might have to play around with this a little bit, guys. Whoops. Okay, well, that works too. Let's do a line endpoint from here. I want to go to this guy. Oh, but you're below. I see. Okay, so see how this line is below and this one's below? We can go to wireframe and we can go to project and we can project these two lines up to the plane. We'll just move them up to, well, the depth would be right here, just like so. Now we should be able to draw a line and connect it to there. Well, maybe we can trim it off after at least, if you're nice to me. Can I divide? Divide. Okay, let's do that. That looks good. And what if I do like a line like this? And can I mirror my element over? Where are you, mirror? can you do mirrors in wireframe? I thought you would be able to. Fillet entities, offset, nope. Project, nope. But can I just do transform mirror? And I will transform this guy, and selection. My mirror will mirror like this. It seems like it already has it right, but I'm going to select my Y axis as this line, and bam. Might as well go right click and clear colors. And let's see if I could extrude these down as well. So let's go to solids, extrude, and you might have to select this little by little. Okay, it went all the way. Now, if I delete this line, it might not like me. So can I copy this line? Hang with me here. I'm gonna call this one wireframe 2. Whenever you're playing with wireframe, guys, I will give you the hint that it is always a fun task. It's always a little bit of playing around, just trying to get it exactly how you want it, which is why I like Fusion a bit better. I'd have a much easier job with it, but for this case, that's fine. So let's do, can we go, well, transform or wireframe? Can I just do project, copy, and just hit OK, and that should project something new. Oh, it did. Why did you not make the, okay, let's move this into change level into wireframe 2. Why? Okay, now it's showing up there. That's weird. Okay, so if I turn off jaw wireframe, that's fine. What if I select you, 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 and you, and you, and you, and let's right click and say move all you guys to wireframe 2. That one didn't work. One second. Sorry, let's do this. Wireframe 2. Okay, and then we will still want a copy of this, this, and this. Sorry, this, and this. And we'll do project. Now it projected it somewhere random, and that's okay. That worked for now. You can see it transformed it down below. And if it goes the same place, I'm not worried. Hit OK. Because then we could turn off our jaw wireframe and we can take and lost. Did I not finish it? There it is. Why were you? I don't get why it's not creating it where I want it to go. 1, 2, 3. Let's right click and say move to wireframe 2. Then that, there we go. Beautiful. Okay. Then we can, I don't want this actually. We'll delete that out. And we can trim off the axis once we lift it up. Okay, so now let's grab this line, and this line, and let's project it again. I know that sounds weird, but I just put those down there just to, for the time being. This time we'll actually set the depth to right here. And we will say move and hit OK. We can now trim off some stuff because we don't need this over here. We don't need this right here. We don't need this right there. Now we have some nice stuff to grab onto, looks like, hopefully. We'll clear colors. Now we can go to solids and we can go extrude, select this, hit OK to the same depth, just like that. I can probably add another chain at the same time and select this one as well. There we go, boom. Now we can turn off all of our wireframe and just look at our obtuse jaws and our part. One thing I never thought of is the radius on the inside of the corner. We know that we can't cut internal radiuses, so we got to add some radiuses into there. Let's see what size of fillet we'd have to do. So if I do this and this, what can we get away with? That is a 0.1. 0.125 would allow us to use a 1/4 inch end mill. What about a 0.1875, which would allow us to use a 0.375 inch end mill, which looks like it's quite a little too big. So I don't mind using a 1/4 inch end mill to cut this. That's fine. We'll do a 0.125 radius in that corner. The other option would just be to have some cutout grooves or corner relief grooves there. Remember that the part is located in the X and the Y off the fixed jaw. This jaw is just to push up against the flat and push it in and clamp it. That'll do nice job. Okay. Hopefully you guys can follow along a little bit easier than last time. And well, we're ready to finish off this part. Okay, so let's take a look at our stock model after op1. Here we are. Okay, I want you guys to note this very, very big overhang. I'm going to open up my OneNote to draw some stuff out. Or not, I'll just take a screenshot of this. Rather you flip it. Just something like this is good for now. Okay, one issue when you have big overhangs like this, if we used a face mill and we cut down and we step down little by little, because of this overhang, when the face mill goes for the last cut, even if we can plan it out well, but no matter what, it tends to always sort of happen. We can try to plan it out better, but we could also just use a 1/2 inch end mill to face this part down to the final size. If you face down right close to where the bottom of the stock is, what's going to happen is the little bit of stock at the bottom is going to bend out of the way, and it creates a very sharp edge and a very loud sound. No matter what, even if we left ourselves like 0.1 inches, when we face that last 0.1 right here, it creates a horrible screeching sound because of that overhang. So one of the strategies is just to remove these overhangs to start with like an end mill by doing like a dynamic rough or something like that, which we'll do. We'll do it that way. Okay. So clear, or those take off. And then, but if we just use an end mill and we just cut all the way down, we roughed it out, starting from the outside, cutting inwards, then we'll cut away the overhangs without them getting too much, without them getting thin. They'll just be getting cut all at once. So we won't have the problem of any thin walls left vibrating quite a lot. So I think the strategy for this facing on the backside of the part will be to use some sort of a facing operation with an end mill. But one thing I really like, a face goes back and forth. And again, we're going to end up at some point with some sort of vibration. When we're looking for something that works from the outside inwards, a really good toolpath is our dynamic mill, which is sort of like our OptiRough. Our dynamic mill can be used for finishing as well. So we'll take a look at this. Let's use this dynamic mill. Let's set our machining regions as the outside of our stock. We want to say from outside, and there's really no avoidance. We want to machine everything off that face because it is a face. Our tool, we're going to go back to our 1/2 inch end mill. We'll go to 12,000 RPM, and we'll go 200 inches per minute for this. And our plunge rate could be 100. Our stock, we don't really have to worry about stock right now. It doesn't need that. We're not doing a 3D operation. Our cut parameters, stock to leave on walls and floors, I believe we can do finishing. So let's show 0 and 0. Step over, let's do 15%. Back feed rate, let's set to 500. Corner depth, no. Finish passes, we'll add one finish pass about 5 thou above. And we will do a feed rate override because we don't want to be doing the finish at 200 inches per minute. We'll slow the feed rate down to 50 for the finish. The spindle speed can stay the same. Linking parameters, clearance is going to be, well, 1 inch as always. We'll set everything to absolute. Retract, I like 0.1 as you guys know. Well, we do got to keep in mind that we want our retracts to be above our part. So that retract might not have been high enough. Yeah, there's my retract. So we might want to move this just somewhere up above the top of our stock. So let's do like what, 0.5? No, that's still not quite there, 0.6. Because our top of our stock is right here. Our depth will be cutting to 0. No breakthrough. Planes, we did set a plane. We just haven't selected it. So let's go select our G55. Go across like that. Coolant can be turned on. And let's see what this looks like. Let's turn off our stock level. I should be seeing 2 cuts. Maybe why am I not seeing 2 cuts? Let's go back into my toolpath. I lost cut parameters. Well, I guess we have to turn depth cut on, and we'll just set it to point, I don't know, 75. It doesn't matter. Oh, finish passes in the X and Y, not, sorry guys. Turn off this pass. That's for your X and Y. We want a finished depth. So we want depth cuts, and then we want one finished depth at 5 thou. That was my bad. And we will override the feed rate to 50. And we'll hit OK. That's better. The only thing you could say about this is that it leaves a kind of a weird finish on your part in the way that you're going to see these kind of weird squiggly lines. So you might, maybe if you really wanted a nice looking part, you could just do a proper facing toolpath with your end mill, and it'd be like nice back and forth. But in the end, I feel like we're going to anodize all these parts anyway, so we probably won't even see that finish if you guys want. Unless if you etch it, so if you do clear anodize, you'll see it. But it looks cool. It's kind of fun to see the tool marks anyways, but a customer might not like that. Okay, there we go. Let's do a spot drill and tap for this 10-32 hole. So let's do drill. Select this hole, hit OK. We're going to select a 1/4 inch chamfer mill. We'll do about 8,025. Drill counter bore. Clearance 1 inch. Absolute, all the way down. Retract can be 0.1. Top of stock is going to be 0, and our depth is going to be about 50 thou. No tip comp. Planes, coolant. My planes are probably messed up because I didn't fix them yet. I'll fix it before the next toolpath. G55, coolant, turn it on, hit OK. Go to my planes and select my G55 and say equals. Okay. But since this is full, what I'm just going to do is copy and paste just to simplify things a little bit more. My tool, though, I will go and select it as my tap drill. Remember, this hole is a 10-32 hole or thread. So if we look at the tap drill charts for our stuff, we see a 10-32 tap drill size is 4.4 millimeters. We can then take a look at our, I guess I don't see it here, decimal equivalent chart. 1 second, let me pull it up. As I said, 4.4 millimeters. Let me just do the quick math. So about 0.173. Let's take a look at decimal or drill decimal chart. Sorry, I'm just searching up. You are the winner today. Point. Let me remind myself one more time. Off the drawing. My bad. 10-32. Sorry, I need to look at my roll tap chart, which said 4.4 millimeters. So let's find our 4.4 somewhere between here. We need a 0.173. 173 is number 17, but let's go bigger instead of smaller. Let's just go up to 177. So our number 16 drill. You probably remember that from last time, perhaps. 0.177, 16 drill, 8,000, 0.0017, double click and change this to number 4, finish, cut parameters. This will be, well, it's a 0.1, yeah, I guess we'll do a chip break. We'll do 0.17 pex. Our linking parameters, top of stock is 0. Our depth is going to be, well, at the bottom of this hole, which is 0.1875, which is the depth that we need for our tap. So we're going to add on tip comp for 1. We'll turn on 0 for now. We want to make sure that we give ourselves lots of room. So let's just go to minus 0.25, as long as we're not breaking through the bottom of that part. We are breaking through the bottom part. We don't have much room at the bottom, actually. That's interesting. So the customer called out, yeah, we can't go that far. It's gotta be minus 0.1875. It can't go much further, because even with tip comp, you're breaking through that part. That's no good. Unless he wants his hole to go all the way through, but then he's machining his way into this back of the boss here. Not good, not good. Okay, we will then have to call the customer and say, hey buddy, you can't get a full 0.1875 worth of tap. So let's turn off tip comp. And that will be good. We'll try to find a bottom tap, which is one that doesn't have too much tapers at the bottom. In reality, you need about 4 threads to really hold on. So we'll definitely get 4 threads, but we would have to tell the customer, hey man, I can't drill that deep and tap that deep because I need to drill a little bit further, but I'm breaking through, right? So you'd have to explain that to them and say, hey, can you a bit less threads? And if they say no, then I'd say, well, you might want to try to push it through the backside. That way we could just push the tap all the way through the part. Drill all the way through the part. So that'll work. And I'll copy this and paste it, and we'll go in and we'll change our tool to select our tool, which is a 1032 tap. So we'll search for a right hand tap. Turn off this equals 1032. Hit OK. Spindle speed should be 1,000 RPM, and that should automatically update our feed rate based off the pitch of the tap, so it feeds the right amount. Yeah, let's change it to tool number 5, finish, and change this to tap. Go to linking parameters, depth is 0.1875. It can't go that deep, so we can try to push to 0.15. That gives us 30 thou to the bottom of the hole. Might as well. What's the worst that could happen? Break a tool. So there's our tap. There's our drill. Should be fine. But our drill diameter was, got to be careful of this, because my drill, when it comes in, oh my gosh, it's not good. See how far up it is? Like, I don't know how I can do that, but let's, this point right here, keeping my eye on it. The tap goes further. Drill full diameter goes down to here, and the tap goes to here. Okay. So we'd crash. We got to push that drill past this So let's try to add some more. Let's go minus 0.2. We can, let's get as much of this hole as we can. Let's go minus 0.225. I'm just gonna keep hitting plus until, ooh, that's leaving us with barely anything on the backside, but it really is just a point, so it doesn't take out that much strength. You could tell your customer, hey, we might be affecting the strength here. Okay, that goes down to here. My tap goes up to, down to here. My drill goes down to here. One more time. My drill goes down to here. Use my finger on my screen. I'll bring my mouse back. And my drill goes down to here, the shoulder. My tap goes to here, a little bit of clearance. That's as good as we're going to get. But when we use a tap, we want to make sure that we use a tap that doesn't have too much waste of threads at the bottom. Like a taper tap, we want to look for probably more of a bottoming tap, which I'm not sure if we do have. Okay, there we go. We solved that. Lastly, we got to chamfer the part, but in my opinion, we should have chamfered the part before we took out the spot drill, because the tool's already in the machine, so we might as well utilize it. So let's move this up below and let's do a model chamfer. And let's just select my geometry, which will be this loop. Oh no, I don't want all that. Just the outside. So let's do single shift click. There we go. Tool is going to be my 1/4 inch chamfer mill, going 12,000 RPM, going 60 inches per minute. It's the speed I like for that. Plunge rate is 100. Cut parameters, it's fine. Now I know I said top offset last time, but bottom offset might be the way to go, because if my top offset is like 50 thou here, it might make my tool come straight down to the bottom of my part, which I'll let it do that and see what it looks like. Linking parameters, planes, coolant, everything's good. So let's just see. Well, it looks good anyways, so we don't have to change it. But you can see if your top offset was telling it something more, then it would crash your tool into the top of the jaws, which we wouldn't want. Okay. Looking good. We can turn off these jaws for now. We don't quick need them on. We can go to our tool paths and we could select everything and we could say go. We can watch this baby cut. Looks good to me, other than again this weird finish I'm getting, but that's somewhere else. 2 minutes, 45 seconds, not too bad. Okay, so for me to save this, let me just position my part, maybe go back to my op1 plane, G54. I can give myself an isometric view from there. Back it off, maybe just say fit to screen. I will turn off all my stock models. And there we go, we can save that there. So now is the time to make our setup sheets. We can open up a similar one, which would be our ENG- why is ENG-003? That's wrong. Sorry, this is my that's weird. That's 004. Oh, that's why I saved over it. Oh, I saved over one by accident. ENG1. Really? Let me just see. I could probably bring it up. Yeah, I definitely saved over my ENG-003 job sheet. Okay, that means I can go here, view online. I'm gonna open up the old one. Just this. I'm gonna save this as, this is meant to be, sorry guys, this is not part of your curriculum. 2. Okay, and if I do this, I should be able to go. Give me 1 second, guys. That's better. Okay, so let's change this to ENG-004. This is our crankshaft. We are using 1x2 aluminum cut to 1.25 inches, I believe. 661 aluminum. Let me bring this up and let's bring up our program. Oh, I should save this before I do that. File. I could restore it again. That's okay. 004. Okay, let's open up my toolpath tree and see my tools that I'm using. So tool number 1 is a 1/2 inch end mill with 0.75 flutes, which is what I need. Tool number 2 is an 1/8 inch end mill. Length of the holder shouldn't matter. I have 16 and 32, but that's my tool 4 and 5. Inch spot drill. And the rest is garbage. Like so. Wait, I'm in the wrong one. What's going on here? Jesus, I'm a mess. I'm a mess right now. The heck? Okay, well, it does not matter. It does not matter whatsoever. Okay, let's keep going. ENG-004 crankshaft. Okay. X0 is my left stock. Y0 is my back stock. Z0 should be minus 0.02 from my top stock. I will give instructions based on how I'm holding it. So in my levels stock, we are holding setup up 1, align up 1 with invice jaw. I'll let them figure out how they want to. Maybe we do it on center, maybe the left side. Align up 1 in vice jaw. 2 align 2-inch side in X, 1-inch side in Y, and 1.1 inch side in Z. We will make sure that if we're cutting down, we could do a measurement from home, from distance from you to the bottom of the part plus 50 thou, remember? 1.01 plus 50 thou, which is 0.06. Let's make it 1.1. ensure 1.1 inches minimum out of vise. Min stock out of vise. Op 2, use custom jaws. Yeah, use custom jaws. Anything else? I should say which jaw is the back jaw, I guess. The flat jaw face. Let's see, I'll say the round jaw. Fix round. Profile to fixed jaw. And flat profile to adjustable jaw. Just so they know how to put the jaws in, because sometimes I get it backwards. And we'll go up here and we'll do this. Op 1, 0 left of stock, Y 0 back stock, Z 0 minus top stock, minus 0.02. Op 2 offsets. Well, my X 0 is going to be jaw bore. My Y 0 is going to be jaw bore. And my Z 0, or my measuring, is going to be bottom of jaw bore. And we have to figure out a dimension between the top or the bottom of the jaw bore and the top of our part for our op 2. So let's go to our, let's turn on our jaws and let's do a measurement from here to the top of the part, which is here. I wish it would have been nice to make this a better number, but that's okay. We'll just move it up that much. Just get it right in, so move it up 0.32222. So move it up from there. 322. Okay, and we don't need anything there. Op 2 offsets. We could fill out this stuff in class if we want. I'm going to leave it for today just to keep your videos nice and short. Other than that, guys, I think that we have ourselves a finished part.